First of all, any non-zero digit is always a sig fig. Zeros can be a bit of a problem though. Zeros in the middle of a number are sig figs. Zeros at the beginning are not. And zeros at the end of a measurement are sig figs as long as they're to the right of the decimal. Zeros that are to the right of the number but before the decimal can be a problem. They may or may not be sig figs. In fact, the easiest way to count your sig figs is not to use those 5 rules. But as you can see under Mr. Spencer's method, there's one step, which we didn't really need to label 1, but it's one and done. You count from left to right. You start counting at the first non-zero digit. Then you count it and all digits to the right, whether they are zeros or not. So I wouldn't begin counting till I get to the first non-zero digit. Then I count it and all digits to the right, which means this measurement has 7 significant figures. Remember, every measurement will have a unit as well, and if you don't have the unit with the correct abbreviation, it's not a measurement in engineering. When recording measurements, it's also necessary to round our results. If the first digit eliminated when you're rounding is 4 or less, we call that rounding down, but we just eliminate the digit that we're rounding off. If the first digit to be eliminated is 5 or greater, we call that rounding up, and we're increasing the last digit by 1. So this answer is being rounded up to 2 significant figures. When we do calculations, there are 3 rules that we have to pay attention to. There's a rule for multiplication and division, and that rule says that when doing multiplication and division, we round off to the least number of significant figures in the calculation. Here's an example of the multiplication division rule. The numerator has 3 significant figures, the denominator has 4, so our answer is rounded to 3 significant figures. The second rule for calculations is for addition and subtraction operations. Whenever we add or subtract, we have to round off the least number of places after the decimal. An example here, the first number has 2 places after the decimal, the second has 5. We report the answer to 2 places after the decimal. And of course we would need to add the correct unit, whatever it is. The third and final rule for calculations is that you only round off after the last step. While you need to keep track of your significant figures stepwise, we don't actually round anything off until after the last step. If we round repeatedly, we will be off from the right answer and you're going to lose marks. Here's an example of a multi-step calculation. We have an addition operation here. The least number of decimal places was 2. The answer is rounded to 2 decimal places, but we keep these digits in our calculator screen, or you can write them to one side, however you wish to keep track of it. If it were a final answer, I would report 26.24 grams. But it's not a final answer, so I'm keeping these digits into the next step. This is a division. During multiplication and division, I round to the least number of significant figures. I'm now ready to report my final answer. I see the next digit as a 5. I'm going to round up and report my final answer to 3 significant figures, 11.4 grams per milliliter. One more thing to keep in mind is exact numbers in calculations. Exact numbers, as the name implies, are exact. They have an infinite number of sig figs. So when we multiply or divide by an exact number, the answer can't be any more precise than the original measurement. The rule is to round off to the least number of decimal places. We'll see exact numbers in counting or averaging, or in definitions from formulas and similar type things. So let's have a look at an example here. This exact number comes to us from a definition, so we're changing our base unit from kilometers to meters. We multiply by a conversion factor here, and this one can be a little confusing because we don't have any decimal places, but we have the same number of digits in the final answer. It's really just a decimal move. This example is a little bit better. We have three masses here. We're adding them, dividing by 3 in order to take an average. And the result, 1.23, has 2 decimal places, just like the original measurements. Another thing to be aware of, it's entirely normal to see the number of sig figs increase or decrease in a calculation when the magnitude of the output changes. In other words, your power of 10. If you go from tens to hundreds, or from hundreds down to tens, it's normal to see the sig figs increase or decrease. Don't worry about that. Just follow your rules, and if you're following the rules, you have nothing to worry about. For example, if I were to take 10.20 moles and divide by exactly 2, I would output my answer 5.10 moles, keeping the same precision 2 places after the decimal. Now, the sig figs decrease from 4 to 3, but that's exactly what should happen in this case. Similarly, but in the opposite direction, if we're multiplying and the magnitude of the number increases, applying the rule and keeping 2 decimal places will mean that the sig figs increase from 4 to 5. But again, they should, and you've done everything properly. One final bit of advice: learn how to use your calculator. If you're using a TI series like this one, if I'm going to enter Avogadro's number, 6.022 times 10 to the power of 23, I don't use the multiplication key here on the keyboard. The way that the TI was intended to be used is for you to use the EE key, and it will display E23. The calculator sees this as 6.022 times 10 to the power of 23. If you try to enter it a different way, you may end up increasing or decreasing the number you're trying to enter by a power of 10. Just use the calculator the way it was intended to be used. Use your EE key for scientific notation. On other models, it may be EXP, but the 10x button is the anti-log, and other ways of entering exponents are not the way the calculators were designed to be used.